Hi, my name is Timur. I'm an optical engineer at NKT Photonics in Coherence Group. And in this group, I'm responsible for optical collimators, fiber deliveries, and harmonics production. So in my hands, I have a collimator. This is high-power collimator, which is in the interface between the fiber optical amplifier and free space. So it's very important that this part has a very good pointing. The pointing, it means that the direction of the beam is very well defined. And this is very important in the application of our amplifiers. For example, if something happens to your amplifier in your optical setup and then you replace it, if you take a new one, you plug it into your setup, and then the direction of the beam is at the same position where it was before. Now I will, right now I don't have light here, but now I will insert it in our setup where we produce and test these collimators and show how we measure the pointing. I'll put on my goggles, turn on the laser. Here in this setup I have two mirrors that are guiding the beam to the detector that records the position of the beam. What I will do, I will just rotate the collimator around its mechanical axis and record the position of the beam. Once I can see the circle that shows the trajectory of the beam on the detector, and I could measure the size of the circle, I can measure the pointing and to compare it with the specification. And I can see that this one, for example, is in spec. Thank you so much.
Hello, my name is Lucas. I'm an optical engineer here at NKT Photonics, and I'm working on designing fibers to deliver light from our light sources to any place you want, really. In this case is our optical table. I want to show you some experiments, some measurements that we do on our fibers. What we are interested in is low loss, high degree of polarization, and we want the output beam to be as close to Gaussian shaped as possible. Let me put my light goggles on. So the first measurement I want to show you, we can see the beam is directed into our m² machine. We will measure the quality of the beam. So we have to wait a bit. So this device gives us m² measurements, the divergence, waist width, waist locations, all those parameters that show us if the beam is good or not. The measurement is ready, and in our case the beam looks very good, very close to Gaussian shaped. Let me show you now how we analyze the output polarization of the fiber. Let me flip this mirror here to guide the light into the polarimeter. So if you could look at the monitor on the right, it shows us the output polarization from the fiber. Let me modify it now with a wave plate placed in front of the fiber. We can see the polarization is rotating. It's also changing from linear to elliptical. We can also see the degree of polarization. And this is some of the measurements we do on the fiber delivery here at NKT. Thank you.